Hello everyone! In this tutorial we'll cover main Microsoft Excel features that will help you to successfully get started with your physics lab reports and data analysis. Here's an example of the assignment that you'll need to complete by the end of this tutorial. As you can see, we have a data table over here. We have distance calculated using formulas. We have a plot with two vertical axes. One stands for velocity, another for displacement. Also, we have a trend line over here and the equation on the chart, as well as simple legend for the graph. On the right, you'll see another type of plot that features error bars. So those error bars could be added for each point of the dataset to show the error for measurements. So let's get started and learn how to do this in Microsoft Excel. But first of all, let's consider a real-life example. We have a car that starts from rest and then undergoes uniform acceleration in one dimension. Let's run this simulation. As you can see, car moves faster and faster each second. That means for each period of time, the velocity of the car will be increased by a constant value. And this process is called uniform acceleration or constant acceleration. So our task is to describe the motion of the car using data in Microsoft Excel. But first of all, we'll need to generate sample data. Usually you take data from some kind of sources of measurement. For example, you can measure time manually using stopwatch, or you can use a special tracking software to measure displacement of the object versus time. But in this particular example, we'll create, so to say, ideal points that will describe this motion, which means it's up to us what time range we would like to use, as well as initial values. So first of all, I will create a time column, and I will measure time in seconds. And I'll start measuring time with 4 seconds until 20 seconds. So I can create a series of numbers like that by entering them manually, or I can use smart Excel features like this. If you select two consecutive numbers and use this square on the bottom right corner, which by the way called fill handle, if you click on this fill handle and drag it to the bottom, you can see on the right there is a pop-up, and this digit represents the ending number of the range that you would like to create. So once you release your mouse, you will see that numbers from 5 to 20 has been created. This can be particularly useful if you have a huge data set. And this technique can help you to create as many numbers as you want. For example, like this. Also, you can delete numbers by clicking on the starting range, which is 291, and then I would like to limit my time frame to 20. So I need to press Shift, hold it, and click on the cell I would like to remove, right? So, and you can see that the whole range has been highlighted, and now I can just hit delete to remove unnecessary values. There you go. So now I have my data range for time. Next step is to create data for the velocity. I'll type in velocity. Also, I would like to adjust the size of this formula bar to make it smaller. Velocity should be measured in meters per second. By the way, if the content of the cell goes outside of the content of the column, what you can do, you can just click and drag the border of the column and stretch it. Or you can just double click on the borderline between column B and column C. And the width will be adjusted to the content automatically. So to create data for the velocity, we'll need to use a formula for the velocity. And in this case, the formula for the velocity is over here. To calculate final velocity, we'll need to know the initial velocity. It could be 0 when it starts from rest, but it could be not 0. When it already started to move by the time we started to measure the motion of the car. And also we'll need to use acceleration times time. we already have time. So we don't need to create anything for time. We just use this data range. But we'll need to create values for the initial velocity as well as acceleration. To do that, let's go over here and add few rows above the headers of the table. So what I can do, I can move my mouse until this cursor changed appearance, then right click and choose insert. This will add one more row on the top and shift all content downwards. I'm gonna repeat it 2 more times. And over here, I will enter a header constants. So I will have initial velocity as a constant. I will call it v0. Also, I need to use acceleration. By the way, when you create content, text has left alignment, but if you enter a number, it has right alignment. Okay, so I will just add equal signs in front of the v0 and acceleration so that it will make more sense. And I would like to change alignment for this text. So what I can do, I can select both of them, and in the top ribbon, select right alignment. Okay, so now they are aligned to the right, and I can enter initial velocity, let's say 4 meters per second, and acceleration will be 2 meters per second squared. By the way, this stands for power of 2, right? So it's seconds in power of 2. Okay, now I have everything to calculate the velocity for each period of time. And I will need to use this formula. So to calculate final velocity, which is this one, I will need to use initial velocity, which is this cell. I'll need to use acceleration as well. And acceleration is over here. And also I will need to use time. And time will be each cell in the column A. To generate data for the velocity, we'll need to use formulas. To start typing formulas, you need to use equal symbol. When you type in equal symbol, you will enter formula editing mode. So we need to take the initial velocity over here, right? Which means it's that value, cell C1. So I can just click on the cell C1 and go. Then I need to add acceleration times time. So I will click on acceleration, then I'll use a multiplication symbol, which is asterisk, and click on the time. There you go. So here's the formula to calculate the final velocity. Right, so when formula is ready, you just need to hit enter. So the velocity of the car at the time 4 seconds will be 12 meters per second. Now what we can do, we can use this fill handle, click it and drag it to the bottom to fill up the rest of the cells. And let's take a look. It looks like we have some kind of issue over here. So in theory, the velocity of the car at the time 4 seconds will be 12 meters per second, okay, but when we have acceleration 2 meters per second, that means at the time 5 seconds it should be 14, not 2. That means we have some error in our formula and we need to fix it. Now let's take a closer look to the formulas. When you click on the cell, you see the result of the formula. You'll need to double click to enter editing mode, or you can click on the formula bar to start editing formula. Right, so as you can see, everything is correct for this formula. We use initial velocity, acceleration, and time. Let's try to check the formula for the motion of the car at 5 seconds mark. So we click on the formula bar, and as you can see, Well, we use correct time, which is 5 seconds, but cells for the velocity and acceleration have been shifted down. And here let's discuss features of Excel. We have cells with a static reference and dynamic reference. And here time is a very good example of the dynamic cell reference, because the reference for the cell will be changed as you copy the formula contains the reference. In this case, we copy the formula downwards, so the time cell reference will be shifted downwards. So this behavior is okay for the time, but the situation with the initial velocity and acceleration should be different. We'll need to make sure they will remain the same as we copy cells down. To do that, we need to revise our formula for the velocity, right? And to make this cell fixed, or in other words, to make the cell reference static, we'll need to use dollar symbol in front of the address for the column and row of the cell. So I'll need to type in dollar sign in front of column and in front of the row I would like to use to create a static cell. And the same for the acceleration. So by doing that, I make these cells static. All right, let's apply the formula. One of the way you can hit enter, or you can use this OK button. All right, so we have applied the formula. And let's try to copy this formula down. I'm gonna just do it once for an example. There you go, now we have the correct value, it's 14. Now let's click on the formula bar. And as you can see, the time cell has shifted as we copied. That's what we expected. But the initial velocity and acceleration reference cells remained at the same place. That means they are static. Okay, so now I can use the fill handle to copy everything down to create velocity data. There you go, now I have correct velocity data. Now let's add one more parameter for the motion called distance. And we'll measure distance in meters. To calculate distance for each period of time under constant acceleration, we can use this formula. To calculate distance over here, we need to know certain values. First of all, is an initial distance, which is represented over here as x0. Right? So which means we need to add x0 as a new constant over here. We also need to know the initial velocity, and we'll already know that. So this is the initial velocity. We also need to know time, and time is provided over here. And also we'll need to know acceleration, and we'll already have the value for acceleration. So let's add a value for initial position. So I will enter x_0 equals, and make the right alignment. So let's say that initial position equals, well, let's say some arbitrary number, 22.5 meters. So here is my initial position. And now we have everything to create a formula. So distance for each period of time is equal to initial position plus initial velocity times time plus 1/2 times acceleration times time squared. Okay, once you complete entering data, you need to click enter. So the value for the distance will be as follows. So let's add more space between headers and the constants. And now let's propagate this formula down below. But first of all, I would like to take care of constants. So all values in a C column, row 1, 2, and 3 should be constants. So now I need to make sure that each of those cells is static. I can do that by adding $sign. Okay, for this one and for the acceleration as well. After that, I can hit enter. And now I can propagate this formula down below, and all values will be pre-populated. There you go. Now I have a data table that describes motion of the car. Now let's learn how to add plots in Excel. To add a plot, you need to highlight columns for the values you'd like to use. In this case, it's going to be time versus velocity, right? So to do that, I need to use insert feature over here in the ribbon panel. We need to use insert. Then for the charts, we need to select scatter and use scatter with just points. So when you click on that, you will have a graph added to your workbook. And now we'll need to do a little bit of formatting. First of all, you would like to remove this title. To remove the title, you would like to click on the title and just hit delete. Also, you would like to remove this grid line. You need to click on vertical grid and hit delete, and you need to also click on horizontal grid and hit delete as well. Now your graph looks much cleaner. Next step is to add more elements. So you can click here and choose axis titles. There you go. So x-axis is time. To change text for the if you would like to change text now, you'll need to change text for the x-axis. You need to click on the title and click one more time to enter editing mode. Now you can edit this title as just regular text. So, and this is time in seconds, right? And the vertical axis is velocity in meters per second. Now, since you have a set of data points, you need to make a fit or a trend line. The way you do it, you need to click on this plus icon and select trend line. Just click, you just need to place check mark in front of the trend line, and as you can see, the trend line is now added. On the right, you will see a special menu called Format Chart Area. And you can select different options, right? So what you would like to format. You can format either chart area or plot area or series. So basically you can change appearance of any element. Usually you represent trend line by solid line, not dashed line. So to change appearance of the trend line, you'll need to click on the trend line first. Then it will appear in the format trend line options. You'll probably need to click on this bucket icon, right? So now you'll see options for the appearance. First of all, you would like to change the dash type over here from dashed to solid. Okay. The style of the trend line has been changed. Also, you probably would like to decrease width a little bit and maybe change color to something different. Now, the next step would be displaying equation of the trend line. So let's go to the trend line options over here. Use data column and scroll down until you see display equation on chart. There you go. Now the equation has been added and we can drag this around to place somewhere in the plot area. There you go. Now the velocity versus time graph looks complete. Next step will be to add time versus distance on the same graph. To do that, first we need to add a new dataset. To add new dataset, you need to right-click somewhere in the plot area and choose select data. So from here, there will be a select data source window pop up. You need to click add, and you will see another window. It suggests you to use a series name, and you can click this button to provide data series name. So in this mode, you can click anywhere, right? And the value for this cell will be used as a series name. In this case, I would like to use distance meters. For the X values, you'll need to enter range over here. You need to select range by clicking this icon and providing a range. So the X range is a time range. So I need to click and drag the selection around all data points for the X-axis. Once you're done, click on this icon again, right? And finally, I will need to provide values for the Y-axis. And in this case, this is distance. So I click, drag, and release my mouse once I selected all the data, right? Now I'll need to click this icon again. And after that, you can see that the new data series has been added to our plot. Finally, you just need to click OK to commit changes. Now we have two datasets, one for the velocity, right, and another for the distance. Let's click OK. Now let's click on any data point for the newly added distance versus time series. Okay, and for the format data series tab, you'll see that we have additional options like this. We can plot series on the primary axis or secondary axis, right? So I will select secondary axis. Now you can see that velocity and the distance data series share the same x-axis but have two different vertical y-axis. We need to add label for the secondary axis as well. To do that, we need to click this plus icon, choose axis titles over here, and click secondary vertical axis. There you go. And provide axis title, which is distance in meters. Just like we did before with the velocity versus time graph, let's add a trend line for the displacement versus time graph. To do that, you need to either click here, right, and click the trend line. Another way to add trend line is by clicking on the series and right click and select add trend line. So now the trend line is added, but the problem is by default Excel will add linear trend line. You'll need to change linear trend line to polynomial. Now the trend line describes these points better, right? So also you would like to display equation on chart by clicking this checkbox. All right, so now you have an equation for the distance versus time graph, as well as an equation for the trend line for the velocity versus time graph. Now, we need to change the style of the trend line a little bit. Again, to change the style of the trend line, you need to click on the trend line, right? On the right, select the fill and line options, change dash type to solid. Okay, also adjust the width parameter. All right, also you can change color if you want to. So I'll select something like this. Okay, now the final touch will be adding a legend. So let's make this a little bit bigger and click this plus icon over here and click checkbox in front of legend. As you can see, the legend has been added. There is no need to provide type of the trend line, so we can select it and hit delete, select and hit delete. Now you have only two things in your legend. And the convention for the legend, it should go inside the plot area. So let's adjust it accordingly. You can click on the plot area and move this to the right, and this will adjust appearance of the plot in general. And let's move legend somewhere in the bottom right corner. Okay, so now this looks complete. Let's move this chart somewhere closer to the data table. What you need to understand in this particular example is that this data is, so to say, ideal case of the data for the linear motion. In real life, you measure all values with a certain error. Now let's pretend we collected data for the velocity using some kind of measurement devices. This could be sensors or video tracking software such as Tracker. And therefore, if you measure something using measurement devices, you should assume some kind of uncertainty. Now, let's say I would like to create one more constant, and I will call it measured velocity uncertainty. And my measured velocity uncertainty will be equal 1.2 meters per second. Now, this is the arbitrary value. For the real life physics experiment, we will have different value. So let's create a table with the header V simulation, and this will be measured in meters per second. So the idea for the V simulation is that I will take the original velocity, right, from the idealized data, and then either add or subtract some kind of random numbers. But these numbers should be within this range of 1.2 meters per second in both sides. So the maximum value of our uncertainty should be 12 meters per second plus 1.2 meters per second. This will give us this value, or minus 1.2 meters per second. So, and I would like to randomize this data to repeat or to simulate real life data acquisition. For that, we need to use advanced formulas. In this case, the advanced formula will look like this. So I need to start entering the formula equals. So I will take the value of original velocity, and then plus some kind of random value. And for the random value, I will use this formula. It's norm inf with a few parameters inside. It's a rand parameter, which is probability. The second parameter is a mean. And third parameter is the standard deviation. And standard deviation is, in fact, should be our uncertainty we have over here, which is 1.2 meters per second. And we need to make this point static, so we need to add dollar symbol in front of the address for the column and for the row for this cell. Okay, so now the formula is ready. Again, that's how it looks like. So it's initial velocity or ideal velocity we have over here, plus norm inf, rand, 0, and uncertainty. All right, so let's apply this formula and see the result. As you can see, we have certain deviation from the velocity we have over here. And now let's propagate this formula down below. All right, and now we have some sort of simulated data for the velocity. Now let's repeat the same procedure as we did before and add a velocity versus time graph. Let's highlight the whole data set, including the header. Then click Insert, and then select Charts, Scatter. All right, let's move this to the right. By the way, you can use this scroll bar in the bottom right corner to slide through the document. By looking at this data, you can see that it looks a little bit of random, right? So it's not an ideal straight line like it was before. Let's remove a header first. I need to click on the header and click delete. Also, I'd like to delete the vertical grid line and horizontal grid line. Also, I would like to add axis titles. On the bottom, I will have time in seconds. Okay. For the vertical axis, I will have V simulation in meters per second. Now, we need to fix one more thing. Let's right click and select data. What we would like to make sure, we would like to hit edit button. As you can see, there is no x values range, so it's not actually time, it's just numbers from 0 to something. We would like to tidy up these values for the actual time, so we need to use this time frame like we used before. Right, so let's click on this icon and hit OK. Now this plot corresponds to the actual time range for our simulation. Let's add a trend line. So there are two ways to do that. One way is to click on any data point, then right click on that and select Add Trend Line. Okay, so the trend line has been added. Next, you need to make sure the display equation on chart is visible. There you go. Let's move it down here. And also we would like to change format of the trend line. Just click on the line and then select Fill and Line options. Right, and dash type is now set to dashed line. We would like to select solid. Also, we would like to make it smaller in terms of width. All right. Also, you can change appearance of points on the plot. You can just click on any point on the trend line, then go to marker and go to marker options and select built-in. Under type, you can change the icon for data series as well as the size. So you can choose this one or that one. I think I'm gonna end up with this one. So now our task will be to add error bars. Also, let's change the appearance of the line a little bit and select different color so that it will be something like this. All right, so the idea for this particular exercise is to add error bars. Just because we have uncertainty, now we can use this to add error bars. In order to add error bars, you need to click somewhere on the graph and click plus icon and check mark error bars over here. By default, Excel will add constant error bars. And by the way, we have uncertainty only for the measuring velocity. We assume our time measured perfectly. So we don't need error bars for the horizontal axis, which is time. So you can select one of the horizontal error bars and all the horizontal error bars for the series will be selected and hit delete. So that we have only vertical error bars. But the value for the vertical error bar, which means the height of the error bar, is set to some kind of constant value that Excel thinks acceptable. What you need to do, you need to change it so that it will represent this value, the measured velocity uncertainty. So to do that, you need to click on the error bar, and on the right, you'll see error bar options. Let's click this icon. And over here, you have several options. Right now, you can see that standard error is selected, but you need to select custom, right? So, and for the custom, you need to provide the value. Let's click on the specify value button. And go now, you have a custom error bars button. So what you need to do, you need to provide positive error value and negative error value. So positive error value goes as a top error bar, negative error value goes as a bottom error bar. So you need to click this range and provide this value, okay? And you need to provide the same value for the negative error value, right? So they will all reference the same cell. Let's click OK. So now you can see that we have added custom error bars that corresponds to the measured velocity uncertainty for our experiment. Please keep in mind, because we used a random function for simulating the data acquisition data, if you apply the formula again, let's say I would like to edit the formula, then I hit enter, all values will be recalculated. And this will be true for anything you enter in your work document. For example, if I enter test over here, keep attention to the trend line. You see, all data points as well as trend line and everything has been recalculated. So that means you would like to select data where all error bars touches the trend line. That's how you know trend line is acceptable. So basically what I can do, I can click F9 again and again until I find something acceptable. There you go. I like this result. You see that now trend line goes through each point including error bar. So no point with the error bar goes anywhere outside of the trend line. So I'll consider this data is good enough, and I would like to create a static representation of this dynamic data. To do that, you need to select a range of the data you would like to use, and right-click and hit copy. All right. So then I'm gonna scroll down a little bit down below, then right-click and use paste as values, so that this data will not be dynamic, it will be static, it will be just numbers. So I click paste. Now I have a copy of the dynamic data that I feel is acceptable. All right, so next step is to copy the same graph for this data. I can just right-click and copy this current graph and right-click, paste it over here. Also, I can use Ctrl+C and Ctrl+V shortcuts. So now, if you click on this plot, you can see the data sets represented in this graph, which is time, right, and simulation velocity, right? So we would like to use this data instead. To do that, you need to right-click somewhere in the plot area and click Select Data, right? So for the select data, you would like to hit edit. And for the y values, instead of this range, you can just delete it. You need to provide a new range, which is this one. Just click, highlight it, drag it, and click this button and click OK. All right, click OK again, and there you go. Now you have the simulated V, right, of your choice with the data that includes error bars, the trend line, and the equation for the trend line. Now we have to cover one more important procedure, that is linear regression. So very often when you work with data like this, where you have a plot and trend line, or you have some linear dependency of a real-life phenomena, in most of the cases you would like to provide error on the slope. A good example will be this data. Over here we have linear dependency of velocity versus time, right? And the slope of this line will be acceleration. So there you go, we have the acceleration over here, which is about 2 meters per second square, but as you know, in physics you have to provide error for your measurements. So for your lab report, it will just not be enough to say, okay, so here is my acceleration. Just because your points are not ideal, you would like to provide an error for this value, as well as error for this value. And to do that, you will have to use special plugin in Excel that's called Analysis Toolpack. So in the following steps, I will show you how to enable this toolpack and how to get an error for these slope values. So first of all, you would like to enable the toolpack. You need to go to File. From there, you need to go to Options. From here, you like to go to Add-ins, scroll down and select Manage Excel Add-ins and click Go. You will see this small window over here. You'll need to place a check mark in front of Analysis Toolpack option, and then just click OK. Next step is to find data analysis. So if you go to Data tab over here and scroll all the way to the right, you will see Data Analysis button. Okay, so you'll need to click this button, and this small window will pop up. From this small window, you would like to scroll until you see regression. So you just need to click on regression and select it and click OK. Now you have one more window pop up, and it asks you to provide input Y range and input X range. So for our plot, we have used this data on the left. So I will click input Y range button, right, and provide Y range. This is my Y range. So as for the X range, I'll need to select time. So I need to click this button and navigate to time section. Here you go. Here's the time range, and let's select the time range. Perfect. Now let's click this button again. Now I need to select more options, and I have output options choice. I can either create a new worksheet in the same workbook, or I can output statistics somewhere in the existing workbook. For example, I can select a cell, this one, and tell Excel, hey, I would like to output all statistics right over here. But this is not good because we have some other data over here, and you just don't want to mess up with a lot of text in one place. So I would suggest to select a new worksheet so that it will just make things cleaner. And I will call it linear regression. So it's up to you how to call it. You can call it error or whatever makes sense to you. And now let's click OK. So as you can see, we have a new linear regression tab added to our workbook. So here's the tab for our data. Here's the tab for the linear regression. And let's take a closer look. We have a lot of summary that contains a lot of statistics, but we are mostly interested in these values. This number and this number should be familiar to you. If you take a closer look on the trend line for this graph, this is the slope of the trend line, okay? And another number is the intercept value for this trend line. Next cell in front of the trend line coefficient is the error on slope. So this value, these two values are very important for statistics. I'm gonna highlight it. I'm gonna just highlight it in a different color. So this is my slope value and error on slope, and this is my intercept value with the error on the intercept. So I'll just provide a different color for them. So now I can finally provide an answer what is the acceleration of the car? And here it is. So if your lab report requires for a graph for some kind of value, just like this trend line with the equation on a chart that represents acceleration, you can edit this label and say that my slope is 2, 0, 1, because I take 3 significant digits, then plus minus this error. I have it over here. If you would like to insert plus minus sign, you can do that from this menu. You can go to insert, then go to the rightmost part of the ribbon and select symbol. And over here, you can select this plus minus symbol, just click on that, and then click insert. So, and this plus minus symbol will be inserted right over here. Okay, so let's close this window and continue typing 0.004. All right, so same way I will provide value for the intercept as well as error for this value. Intercept equals to 415. Then I will need to use this plus minus sign again. I can just hit Ctrl C, Ctrl V to copy and paste it. And then value for significant digits will be 0.49. All right, so here's the proper way to provide slope together with the error on slope. However, if your lab report asks only for a table or a data table and you don't have to create any plots, you can just use values right away from here. So here is your value that has some kind of linear dependency, and here's the error for this value, as well as here's the value for the intercept and the value for the intercept. That's it for this tutorial. I know there are a lot of steps, so thank you for your attention. Just a reminder that when you enter something, these values will get updated. That's normal. That's how Excel works. So that's why we created a sample of the static data so that you can use it to create a final graph that will not be changed when you save your document. Also, for your work, you can change any initial values, so don't hesitate to select different time range and different initial values as well. Thank you, bye-bye.